This is lesson 7.2 for pre-algebra, multi-step equations and distributive properties. Now, 7.2 is solving multi-step equations again, but there's going to be some added things. So we're going to combine like terms before we can solve it. So here's an example. 2x plus 7 plus x equals 16. So before you can solve the equation, you need to combine like terms. So I'm going to add this x and make it 3x plus 7 equals 16. Then what I can do is I do my addition and subtraction. So I'm going to minus 7. So then I get 3x equals 9. Divide both sides by 3. So x equals 3. Now I can check it. 2 times 3, so I'm right here at the beginning of this equation. 2 times 3 is 6, plus 7 is 13, plus 3 is 16. So I know I got the answer correct. X equals 3. So, basketball scores. One basketball team defeated another by 13 points. The total number of points scored by both teams was 171. Solve the equation P plus P minus 13 equals 171 to find the number of points P scored by the winning team. So here's what it is. The winning team scored P, okay? They lost, or the other team that lost by 13 points. So their score is right here. P minus 13, that's their score. And then they had a total of 171 points. So I combine my two P's, make that 2P minus 13 equals 171. I'm going to add 13 to both sides. So 2P equals 184. And then I divide by 2. So the points of the winning team was 92. So 92. Now we can check it by putting it back in. 92 plus 92 minus 13. Well, 90 plus 90 is 180, so that'd be 184. Minus 13 equals 171. So I know that that is correct. All right. So in this section, they also talk about finding consecutive integers. So this is a key term that you need to write down in your notes. It says, when you count by ones from any integer, you are counting consecutive integers. So 120 and 121 are two consecutive integers. They're just in a row. Two integers that are in a row. Three consecutive integers could be -5, -4, and -3. It's just three integers all in a row. Okay, so here's what the problem looks like. The sum of three consecutive integers is 96. Find the integers. So this might be a little confusing, but first you start with your first integer. Let's pretend that our first integer is x. And I always have to put a number in just to think of it, okay? So let's say we think our first integer is 30 because we got to get up to 96. So if I want three consecutive integers, how would I represent 31? Well, I have to use my x, so then I would do x plus 1, because that's the next integer after 30. It would be 31, and it would be x plus 1. So then if I wanted three consecutive integers, that'd be 32. So then it would be x plus 2, because think of it this way, x is 30, remember? So then the next number would be 30 plus 1, so that would be 31. And then the next number would be 30 plus 2, so that would be 32. So then they would all be consecutive integers. However, we don't know that it's 30. We were just estimating. We were just guessing that it's 30. So if I clear off all those, I'm left with just a simple equation. I have my first integer right here. I have my second integer, consecutive integer, it goes right in a row, and then my third one is here, and that goes right in a row. So then now I want that to equal 96. So I can find out what my first integer is by solving this equation. So x plus x plus x is 3x, and 1 plus 2 is 3, equals 96. I'm going to draw my line. I'm going to minus 3 from both sides. So 3x equals 93, and then I divide by 3. So x equals 31. I was very close when I guessed 30. So x is 31. So my three consecutive integers would be 31, 32, and 33. Now add them up. 31 plus 32 is 63, plus 33 is 96. So I have three consecutive integers that add up to 96. Kind of like a fun math trick kind of type of thing. So find four consecutive integers with the sum of 358. So try this problem, push pause, and then we will go over it. Okay, so I want four consecutive integers. So here's my first integer, x. I'll color code them so you can see. My second integer is x plus 1. My third is x plus 2. And then my fourth is x plus 3. So those are consecutive integers. They'll go right in a row. It would be like, let's say we had 10. 10 is x. 10 plus 1 is 11, that's green. 10 plus 2 is 12, that's red. And 10 plus 3 is 13, that's black. So it would go 10, 11, 12, 13. They're all consecutive, it works. So I'm going to add them all together, and I want them to equal 358. So x, so I'm going to add my like terms. X, 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 and x. So that's 4x plus 1, 2, 3 is 6 equals 358. I'm going to minus 6 from both sides. So then I get 4x equals 352. And then I'm going to divide by 4 to find out my first number. So 352 divided by 4. 4 goes into 35 8 times. That's 32. And then I have 32 down here, so it's 8. So my first number is 88. And then 88 would be x right here. X plus 1 is 89. X plus 2 is 90. And x plus 3 is 91. So my answer is 88, 89, 90, 91. And you could add them up and make sure that they equal 358. All right, now here's another little spin they like to put on it. For consecutive even integers, the first is n and the second number is n plus 2 because I want it to just be the even numbers. I want to skip that odd number. So find two consecutive even integers with a sum of 66. So my first one would be x. That's my first number. So let's pretend that it's 10 because that's even. Now the next consecutive even integer would be 12. And I would write that x plus 2 because it would be 10. That's my x. And then I'd add 2 and that would give me 12. So that's what they mean by x and x plus 2. These are consecutive even integers, and I want it to equal 66. So x plus x is 2x plus 2 equals 66. I minus 2, so 2x equals 64, and then I divide by 2, so x equals 32. Oh, no, and 34. Sorry. It has to be two consecutive integers, even integers, 32 and 34, and they have to add up to 66. So if you add them together, they equal 66, and they're both consecutive even integers. All right, so lastly, it's about using the distributive property. So when you have equations and you have the distributive property, you're going to take everything on the outside of the parentheses and distribute it into the inside. So this would become 6a plus 18. So many kids want to just do 6 times a and do 6a plus 3. That 3 also gets distributed to the 6, so don't forget to distribute it 2 times. So here, remember it's multiplication, so I can do 2 times 3b and get 6b minus, don't forget the minus sign, 2 times 4 is 8. So then here's the example. They want you to solve this equation. 2 times the quantity of 5x minus 3 equals 14. So I'm going to do 2 times 5x, which is 10x, and 2 times negative 3, because that negative sign goes with the 3, is negative 6, and that equals 14. So now I draw my line, I add 6 to both sides, so 10x equals 20, and I divide by 10, so x equals 2. And you can check your work. 5 times 2 is 10, minus 3 is 7. 7 times 2 is 14, so I got it correct. So try these 2 problems, push pause, and then we will go over them. All right, here I'm going to do negative 3 times m and get negative 3m. Negative 3 times negative 6 is a positive 18. Don't forget that that negative sign goes with that 6. Equals 4. So then I'm going to minus 18 from both sides. So then I have negative 3m equals negative 14, and I divide by negative 3. So this becomes m equals negative 14 divided by negative 3 is a positive 14 thirds, or 4 1/3. That is a tricky one. They usually aren't that intricate. Okay, next is 3 times x is 3x. 3 times 12 is 36. Minus x equals 8. So I'm going to combine like terms. 3x minus x is 2x plus 36 equals 8. I'm going to minus 36 from both sides. So 2x equals negative 28. And then I'm going to divide by 2. So x equals negative 14. All right, that is it.